Hey, it's Mr. Worst again. Um, Electricity calculations. So I got two triangles of destiny here. One relates voltage, current, and resistance. That's V equals I times R. Okay, so we have those all three equations right here that you can get using algebraic manipulations. So voltage equals current times resistance, current equals voltage divided by resistance, and resistance equals voltage divided by current. All three of those things you can get from this relationship, V equals IR, which is also called Ohm's law. Now there's another relationship that we have for you, and that relates power, voltage, and current. So power equals voltage times current. By the way, P equals power here. Current equals power divided by voltage, and voltage equals power divided by current. Hopefully you can see my cursor right there. Anyways, you're going to use those equations down here. So calculation set 1, these are all the same questions. So you see here, this is a screenshot that I took. I made it in Google Slides. Anyways, so question 10, what have you been given in this scenario? So there's the scenario here. What have you been given? I'm not going to tell you the answer, but I will go and show you a similar task. So on day 23, oh wait, right here. Okay, so maybe you saw something like this in our class where like you need to calculate resistance and it was voltage divided by current. You were given 120 volts and 5 amps as the current. So you divide those two and you get 25 ohms. That's not an octopus. That is an omega. It just looks like an octopus. So there's another question where you're asked about finding a voltage, which is current times resistance. So you multiply those two things you were given, yada, yada, yada. Anyways, I'm going to scroll through this. You can pause the video if you want to go back and look at things that you want to find and how to calculate them and how to relate them. But I think it's pretty straightforward. So we've done this process now for this is our 6th unit total because we did 3 units in both quarters. So yeah, you got this. We believe in you. The next equation you're going to use is power equals voltage times current. And here are some examples here. They're itty bitty tiny living space. Let me zoom it in for you here. Boom, bigger. Okay, so for example, power equals voltage times current. So in this equation, you were given the voltage of 120 volts, the current of 5 amps. You multiply those two together, and the answer comes out in watts. What? Watts. Watts, which is a coulomb per. Is it a coulomb per second? Doesn't matter. Power's in watts. Don't worry about what watts are. I don't want to confuse you. Okay, so, or confuse myself. I have to go look it up, but I only have 5 minutes for this video. Plus it takes like an hour to upload because my internet's really slow right now. Anyways, so yeah, I just scrolled through some example problems. You can pause the video, zoom in if you need to, but power equals voltage times current. So voltage also equals power divided by current. You're going to do some similar problems here. So calculation set 1 is asks you the question, a toaster uses electricity from an outlet at 120 volts. The electricity goes through the toaster at 4 amps. What is the resistance of the toaster? So you need to say what's given. Question 11, what are you wanting to find? Question 12, what's the formula? And question 13, what's the work and answer? Similar process for calculation set number 2. What have you been given in this scenario? There's a new scenario here, similar, but a little bit different. What is the power of a toaster with a voltage of 120 volts and the current of 4 amps? Okay, so question 14, what have you been given? 15, what do you want? 16, what's the formula? And finally, 17, what's the work and answer? That's it for this section. In the next video, we'll talk about electronics, but good luck on these calculation questions.